You. Here we go. No. You should be keeping your purple and pink paper and then your blue paper. So knowledge folder papers and then any notes that you have from chapter 4. Okay. So we started chapter 4, but anything with logarithms, imaginary numbers, quadratic formula, linear, that can all go away. So anything from chapter 1, 2, and 3, except the blue paper. Jack Vandenberg, don't throw away the blue paper. And don't throw away the purple paper either. I did say that, right?
Don't get rid of it.
Yeah. Hey, that purple paper in there. You got 3 of them.
I'm not sure.
Yep.
Chapter 4 notes a handout, or do we write those down?
Well, if you're a note taker, you wrote them down. Okay, no handout. Okay, it's
Everything else can go.
behind there. Yep. Okay, so we are just going to do a little bit of review, and then we will also start some new stuff today. So first of all, we talked about the fact that the angle that we use, the variable that we use for angles is called theta. Okay, theta is a Greek letter. And not know what its English equivalent is. It's just theta. So let's do M, P, and Z. So we talked about the fact that there are 3 main trigonometric ratios, sine, cosine, and tangent. That's going to help you a lot if you can remember SOHCAHTOA. And the spelling of that is the key. So if you can't remember it, that's a problem. Because SOH is sine, opposite, hypotenuse. So you got to know how to spell those things. If you can't remember them, they're on your purple sheet. What I would like you to do is to find for me the sine, the cosine, and the tangent, and the cosecant, the secant, and the cotangent of theta. Please. Okay, we did do this. If you're like, hey, I have this in my notes, different letters, same thing, and you don't want to write it down, that's fine. But you gotta know how to do it. There's a P and a Z. M, P, and Z. Okay. What is the sine of theta? Yep, P over Z. Sine is opposite over hypotenuse. So remember that the opposite side, if this is theta, the opposite side is enclosed in the 2 rays that make up the theta angle. So they include the opposite side. What's cosine of theta? Yep, m over z. So adjacent means next to, and tangent is what? P over m. Once you have those three done, the other three are easy. You can look at the purple sheet, but if you remember that they're reciprocals, life gets a lot easier for you. What is the cosecant? Yep, z over p. Secant is? And cotangent? M over p. I can't remember if I changed the test last year, but for sure there was like three of these, a question like this on the test, at least from 2 years ago. Can't remember about last year. I might have changed it, but like literally that's easy stuff. So we talked about those guys. We're gonna do another one like we did on our warm-up. We're gonna do a couple of those because there's some things that I want you to remember. So let's say let's go sine of theta is 6 over 13. Find, let's go tangent of theta. We did these problems. We had them on our homework. We did them, and they made you find all 6. I'm not really likely to make you find all 6 because it's the same amount of work. It's just less writing. But if you just find tangent. So this is like what we did our warm up. Remember that what this gives you, it's easy to look at sine as being one thing, but if it's a fraction, then you can break it up into its parts. So sine is opposite over hypotenuse. And so this is giving you information. It's giving you 2 sides of a right triangle. Okay, you can put your theta anywhere. Put it in the top, put it in the bottom. It doesn't matter. It's just not 90. Okay, now, you know what? I should have told you this. I'd like us to find the exact value. Okay, my fault. Because if it's not exact value, there's no difficulty to this problem. So when we talk about exact value, that means it cannot have decimals in the answer. Okay, exact value means you cannot have decimals in the answer. So when you go to do the Pythagorean theorem, let me pause and remind you, and this is a quick review, that the hypotenuse is always c, the other 2 sides don't matter. So a squared plus 6 squared equals 13 squared. So this is 36. That's, I think, 169. So we have a squared equals 133, right? Is that right? Okay. So if I cannot use decimals, then I need to leave this as the square root of 133. Okay, so if it's exact value, sometimes people are like, I hate that. Just leave it as a square root. It's fine. Okay, now you have your missing side. What's the tangent of theta? Okay. Now, 2 things that I wanted to review this, 2 reasons why I wanted to review this with you, to remind you that exact value means no decimals. And the second thing is we are not allowed to have square roots on the bottom of our fractions. Okay, and we have that. So we have to do a thing called rationalizing the denominator. And the way that we rationalize is we multiply by the square root of 133 over the square root of 133 in this case. Because what is that fraction that I put on there? What's that equal to? 1. To multiply anything by 1, it's equivalent. We're just multiplying it by the thing on the bottom because we don't want the square root on the bottom. So this is easy math. Like to multiply these guys together, it's 6 times the square root of 133. You literally just smush them together. Super easy. Yep. What's the bottom? 133. Okay. The reason why, you don't have to write this down unless you can't remember. This is this times itself, which is that squared. And the square and the square root cancel each other out. So this would be how you would write your answer for the tangent of theta. It's ugly, but it's true. Let's do one similar to that. So we're working with exact values. I don't really want to write it down the whole time, but I suppose I can. So let's say that we have the tangent. I don't really want that. Shoot. I had a good example first hour and I can't remember what it was. No, I am not. You bum. Okay, there you go. I want you to find the exact value of, let's go, cosecant of theta. Correct. Fractions not on the bottom either.
What did I do? I'm gonna wait. Hold on. What did I do? I have it. Yeah, I get it. It's a square root. Why?
You can't.
You can't.
What?
Can you have a square root on top?
We're just right here.
You just can't have it on the bottom.
Just can't have it on the bottom.
Right on, Jax. Jax, do you think he's with me? Thank you.
Okay.
Give a bucket.
So, this tangent is, you can put it wherever you want, put it top, bottom, it does not matter, but tangent is what? What two sides does that give you? Yep, opposite and adjacent. So you've got a squared plus b squared equals c squared. What is c? Square root of 29. Correct. Does not simplify. The square root of 29 doesn't simplify. So cosecant is hypotenuse over opposite, right? Yes, no? Okay. Cosecant is hypotenuse over opposite, so pretty easy. Hypotenuse is square root of 29, opposite is 2, and you're done. Don't have to do anything to that because the square root's not on the bottom. Okay, which is the question Lawson asked. All right, let's do one more like that. Let's say that cosine this?
Oh, yeah.
Nope. I could do that in my head. You can do that in your head. So let's go cosine of theta is equal to square root of 5 over 13 And I would like you to find cotangent of theta. Okay, cosine is square root of 5 over 13. Oh, never mind. I mean, just do it. It's fine. It's not what I wanted it to be, but that's fine. Yeah.
This Dougie.
Yeah.
How much I gotta pay you to take me for a ride in your car? The charger. How much? It's like took Miss Cook's daughter to get it, huh?
Yeah, I was just helping Miss Cook out.
Run some errands, huh?
Well, dropping her off to an appointment because Miss Cook had class.
How much?
$25.
Ooh. Is that thing at the 130?
Done there.
Ooh. Alright.
I know, you divide it by 2 times, but I know it's 2 times 2, which is 4. Or since it's 2 squared, that's sort of a square, that is square root is 2. So then it's not here. So it's 2 square root of 4. Wait, and what is that? That is opposite. That is opposite. So the highest is multiplied by 2
That's why we're talking about this. Okay, so when you should have this cosine is adjacent over hypotenuse, so you have adjacent and hypotenuse wherever you put your theta, doesn't matter. So you have a squared plus square root of 5 squared equals 13 squared. So a squared plus 5 equals 169. So a squared equals 164 square root. Listen, this is why we're doing this one. This has to be simplified. So to remember that, like you got to start dividing. I'll start dividing by 2, which is 82. Divide by 2 again, 41. And that is prime. 41 is only divisible by 41. So what you have to remember, this is a little sketchy on the exam. By the way, if you want to see your exam, you can come and see me during success. I can let you look at it. We're not going to go over it though. So it's 2 of these on the right-hand side that make one of them on the outside. So this is 2 times the square root of 41. Okay, so cotangent is adjacent over opposite. So adjacent is square root of 5. Opposite is 2 square root of 41. Now, this is another reason we're talking about this one. So if I want to rationalize this, what do we want to multiply by? You can multiply by 2 times the square root of 41, but you don't have to. You do need to multiply by square root of 41. If you multiply by the 2, you're going to end up creating extra steps for yourself. It's not going to be wrong. You just will have to reduce it later. It will work. But easiest is to just multiply by the square root of 41 over the square root of 41. Okay, that's still equal to 1. So you can multiply that. When you multiply 2 things with square roots, you multiply them under the square root and put them together. So I think that's 205. So it's the square root of 205. I better make sure. Okay, square root of 205. And this would be 82. 2 times 81, or 41, sorry. 2 times 41 is 82. Let me show you. You don't have to write this down. Let me show you what happens if you would have multiplied by 2 times the square root of 41. Okay, it's legal to do. Okay, this would be on the top. It would be a 2 and the square root of 205. Sorry, this is making a big mess. This would be 2 times 2, because those guys are on the outside. So 4 times 41, 164. These guys would reduce to 1 over 82. So you're just creating an extra step for yourself if you multiply it by the 2. It's not wrong. You just have to remember then that you would have to reduce it. It's just easier to multiply it only by the square root thing. Okay, those are the things that we talked about before break. So let's talk about new stuff. What we use trigonometry for is finding missing sides of triangles. And we use it also for finding missing angles. So, for example, let's say we have this guy, that's 42 degrees, in case you can't see him, 42-degree angle. And this is 14, and we need to find the missing side. Okay, so I cannot find the missing side using Pythagorean theorem. Why, Mawson?
Because you don't have it.
Have what?
The side.
That was a lame recovery. Jack, you want to help him out since you were who he was talking to?
The second side you can't do.
You gotta have 2 sides. Okay?
So I got it right. You got it right. Just
No.
I don't have the side.
Why can't you find the missing side? Because you don't have the side. Good logic. You need 2 missing sides to use the Pythagorean theorem. So we use trigonometry when we don't have 2 sides, but we do have an angle. So 1 side, 1 angle, and you can always use trigonometry to find missing side lengths. So the way that you do this is you look at what you have. Here's my angle. So what is this side in relationship to that angle? It's opposite, right? So this is opposite. What's this? Yeah. And so it's what you have what you have and want. So opposite and hypotenuse that determines for you whether you're using sine, cosine, or tangent. Which are you using? Yeah, you're using sine. And you probably did do this in geometry. So it's the sine of what angle, though? Yeah, the sine of 42 is equal to the thing we don't know over 14. Now, before you solve this, let me tell you that you need to go to the mode on your calculator. Okay? So, and you need to be in degree mode. Probably most of you are. Yours is going to look a little different than this. Make sure that it is in degree mode and hit enter. There's definitely one of your classmates first hour that I said the same thing, and then they were like, my calculator's broken. I was like, you didn't turn it into degree mode. Okay. Now, once it's in degree mode, you can solve this. What are you going to do? Yeah. Multiply sine times 14. So sine of 42 is a number. Like you can put that in your calculator. That's that. Or just put the whole thing in. So 14 sine 42. It was like that. So the answer is 9.37. Then it would be 0.368. So what a shame. Okay, so why don't you, let's say this is, let's about 20 degrees on that. And this is 14 again? No. Let's make him 8 and let's find x there. That's 20 degrees, not 26. Looks a little sketchy. 20. Okay, so first question, when you see a question like this, the first thing you need to ask yourself is, which of the 3 are you using? I guess you're jumping steps, but what do you have here in relationship to the 20? Opposite and? So those 2 things put together direct you to use which ratio? Tangent. Yep, so it's the tangent of 20 is equal to the opposite over the adjacent. And then to solve that, we'll multiply by 8. Let's put it in your calculator. So you get 2.91. If you want to go 3 decimals, 2.912. Okay, try this one. Question back there? Or are you just arguing? Okay, well, what's your question? Did you just blame it all on Mawson?
No, he was asking me.
Oh, what's your question?
Like cotangent.
So okay, so right, you don't. So it would, we just don't use it for this. There's no value over using cotangent, even if we could put it in our calculator, because cotangent is still opposite and adjacent, right? And so it just doesn't make any sense. You just go with the big 3. That's a good question. Yeah. Yeah. Sign out for me, please. Yep.
So if you have that, right, you multiply the x over.
Great question. This is why we're doing this one. Okay, so are you using sine, cosine, or tangent on this? Cosine. So you should have cosine. 65 equals 10 over x. Now, we talked about this last semester, which I know. But when you have your variable on the bottom and you have stuff on the side, you can switch those 2 things. Okay, we talked about when we were solving log equations, but the principle is still true. So you could, Joey said, you just multiply by x. Yeah, you could just multiply both sides by x and then divide. But if you do this is just a step skipper. Okay, so just swap those 2 and you have x equals 10 divided by the cosine of 65. Only helpful when the x is on the bottom, but it's a nice thing if you can remember it. Put it in your calculator. So it should be 23.66 is the correct answer. Okay, you can't. Because this is what Mawson was just asking. There's really no benefit to doing that. The only benefit would that be that you would have the secant of 65 is x over 10. you would only have to multiply by 10, but if you know the shortcut, it doesn't matter. It's the same amount of steps. Yeah, and then divide by the cosine of 65. Okay, questions? Okay, so let's do this. I forgot to do this first hour, so I'll have to do that tomorrow. I'm sure they would love that. I know that. Okay. It's a little bit different. So what's different about this one? I'm asking you to find the angle. You're given two sides. You could find the third side, but it's not helpful. Okay, so this is still trigonometry. Pythagorean theorem won't help us here because that's only for sides. So still the same principle. What sides do we have in relationship to the angle we're looking for? Of opposite and hypotenuse, which is sine. So it's still a true statement. Sine of theta is 13 over 21. Okay. Now, this is a little bit of solving an equation. We would like to get theta by itself because we want theta. And the way that we do that is we use this guy, this sign with the -1. It's called sine inverse. Those cancels each other. Inverses cancel each other. We know that from logs and exponentials. So in our calculator, we are going to put sine inverse of 13 over 21. Okay, so that's easy to do. Sine inverse, you just do second sine. Like that. Looks like sine to the -1. And you do 13 over 21, which is what it was. There's your angle. That's 38.25 degrees. Okay, so what I need you to know is that sine inverse, cosine inverse, and tangent inverse, for what we're doing with them right now, those give you angles. So you use those when you're looking for angles. Did he just say new year, new me?
Yes.
That's so nice. Okay. Please find theta for me. For our last one like this, I'm going to switch gears a little bit. Okay, sine, cosine, or tangent? Correct. Tangent because opposite and adjacent. So tangent of theta is going to be 7 over 9. So what I put in my calculator is tangent inverse of 7 over 9. Okay. So you should get 37.87. 875 if you went to 3 decimals. Okay. Questions? This is not things that we did last semester, but they are things that I'm thinking that you did in geometry class. Okay. Should be, I mean, that's a ways back. So let's move forward a little bit to things you probably did not do in geometry class. I'm not sure on this one, but I would guess no. Not in geometry class. So we got 3 terms that go with this. No.
I don't know everyone in this room.
What was that one thing we played in the beginning of the year where like they went up to the cop, like stood up?
Oh yeah.
Just
Yes, let's
the
do that.
categories.
You can't just
Yo,
take
I
one.
won that. I
There's
beat
the
Cole.
big problem.
I beat
Please.
Cole.
What did you do?
You beat Cole.
Yeah, I did.
No.
Cole didn't know enough cereals. I did.
Oh, high school, wasn't it?
Oh yeah, it was like.
Oh, I'm glad you remember that. That makes me happy.
You want to make you more happy?
Would it? Do you want to know what would make me happy if we stayed caught up at first hour?
We've been taking notes all hour.
Many.
First days, so-
Have done and will do. Okay, so this guy's called an angle of elevation. Okay, angle of elevation is always made with the horizontal and up. Okay, hence angle of elevation, because it's up. The important thing to remember about angle of elevation, so we're gonna get into some story problems, this is where we're getting. If you see the word angle of elevation, the first thing you should be drawing is horizontal and then the ray that goes up. Okay? Super important. If you don't do it that way, you're going to get the wrong answer. This could be this way also. First hour asked me that question. They're like, what if it's the other way? Is that still horizontal and up? Horizontal and up. So yeah, so it doesn't matter which way you draw it. So those are both angles of elevation. There's this guy. I'll draw it and see if you can figure it out. This guy. One of my rocket scientists in first hour said the angle of de-elevation, which is no, not true.
De-escalation.
Nope.
Dissension.
Nope. Okay, those are good ones. It's an angle of depression. Okay, angle of depression is horizontal and down. Super important because, well, we'll get to that in a second. Now, the last thing that you need to know, the last definition that you need to know is called line of sight. Okay, line of sight distance is going to sound like how I would explain it to a 2-year-old, but whatever. It is what it is. Line of sight distance is if you could shoot lasers out of your eyeballs. I know, very exciting. If you could shoot lasers out of your eyeballs, this and see it, that would be line of sight distance. Okay, it's the path that your vision takes. Line of sight. It makes sense. Line of sight. Okay, it's the path that you're looking along. So, here you go. Until first hour, this is one of my favorite lessons to teach, but they're a bunch of bums, so I know. I would like you to know that this is one of my favorite lessons because I'm a fantastic artist, as you can tell by my line of sight, man. Okay, so let's say, here's your first example. What's going on? Let's see. Bob is laying on the ground. Staring at his kite. Okay. We're going to start out fairly basic on these equations or on these problems, and they will get harder. So if you're like, wow, I can totally do this, that's good. So can I. I'm proud of you that you can do them. They're going to get harder. My thought to you is you can either draw a nice detailed picture, which I don't care if you don't. She got Bob. He's laying on the ground. I'm thinking he's on his stomach with his feet.
He's on his stomach.
Well, I think he's laying on his stomach, right?
Okay, that makes more sense how the drawing's there.
Okay. Looking up at his kite. Right? Whoop, there you go. Look at that. What a fantastic drawing.
That's beautiful.
I know. Carson is admiring my artwork. I know. I saw him doing it. It was no skeptical look on his face at all. So you can draw the picture if you want, but if you're like, no, I don't need to draw the picture, don't. What you know is that because we are talking about angles, because you have a 45 degree or whatever I said, 52 degree angle, you know it's got to be a triangle. You know it has to be a triangle. So what I would do is come in here and put in what I know. Okay, here's my triangle. I know that we're talking about this angle. Why? Nope. Because it says angle of elevation, which is from horizontal and up. So with the angle of elevation to the kite, that means we're looking at the kite and we're relating that with horizontal. So here's the right triangle, like that. Okay, now the angle of elevation to the kite is 52 degrees. And the kite string is 200 feet long. Am I looking for opposite or adjacent? I'm looking for opposite, correct, because I want to know how far off the ground is the kite. So it's the same things that we were just doing. It's just that you have to put the things in the right place. Question?
Is he like holding the string? The string's
Yeah, I'm thinking he's...
Oh, because it was hanging off here, so I was like...
That's his tail. That's the kite tail.
Oh,
Kites have tails.
okay.
His string is the dotted line there. He looks a little bit that way. Okay. So sine, cosine, or tangent. So sine of 52 is equal to opposite over hypotenuse. And then it's exactly the same problems that we were solving earlier, just different numbers, which is not exactly the same.
So different numbers in story problem.
Yeah, different numbers in a story problem. So it is 157.6 feet off the ground. Now, here's my next question to you. What if instead of laying on the ground, Bob was actually holding the kite? So same situation. Here's the kite. Boop. There's this. Kite string is 200 feet long. But this right here, let's say Bob's hand is 4 feet off the ground. This is 52 degrees. So same situation. Right, it was 161.6 because now Bob's not laying on the ground, right? Now the kite string is another 4 feet off the ground. So you want to watch for those things because you will see that in some of the problems that we will do. Okay. I would, if I was you, prepare myself for homework tomorrow. Okay, homework tomorrow, but not today.
I never did that.
I don't know. Not